What's going on, guys? Mr. Allen here, and we're about to identify conic sections from these awful forms. We're not in standard form. I'm not even going to write it in standard form, but there are some key pieces we can look at to make it a lot easier on you. All right, good test question here. 4 options, identify each one, right? So the first one here, I have 2x squared, and I have positive 1y squared. So both my squared terms are positive. However, they have different lead coefficients. That means that this one is an ellipse. So both squared terms are positive, but they have different coefficients, right? If they were the same coefficient, then we're dealing with a circle, all right? And this is also, we should know that this means that they're on the same side when we're analyzing this, all right? I can't have an x squared on the left-hand side of the equation and a y squared on the right-hand side of the equation, because then to get it on the other side, it changes sign. So we do need to have our squared terms on the same side of the equation when we are analyzing this. All right, next one. I have x squared and I have y squared. I'm only looking at my squared terms here for this. So for that one, I have both positive and both of the same lead coefficient. Therefore, it is a circle. So once again, the thing you should be jotting down in your notes would be that it's a circle, and the reason is both squared terms are positive and they have the same coefficient. All right, next one. I only see one squared term. What the heck does that mean? Well, that means it's a parabola. So jot that down. That's kind of the oddball, right, in conics. Everything else has both terms are squared. Parabola, only one squared term. Quick and easy to identify. The last one down here, I have an x squared and then I have a negative 16y squared. Since one of them is positive and one of them is negative, that's a hyperbola, okay? Even if they were the same, like it was x squared and just minus y squared, there was no 16 there, it's still a hyperbola, okay? It doesn't have to have different coefficients. It often does. But the only thing that you need to identify that is that one is positive, one is negative. Boom. Let's jot it down. All right, there we go. Hyperbola, one is squared, or one squared term is positive, one squared term is negative. Boom. There we go. We don't even need to worry about that number once again. The number that's there, the 16 doesn't matter. It could have been a 3. It could have been a 1. All right. But there we go. We got all 4 of them. That's awesome. So we don't even need to complete the square. Write it in standard form. Oh my gosh, so much work. You can identify them right from here by looking at your squared terms. All right. You guys have a wonderful day. I'll see you later.